We're going to be talking about complex numbers. Now, when we have complex numbers, that simply means that our number is going to have an I in it. And just so that we can know, an I is the same thing as the square root of a -1. So whenever you see I, just think to yourself, okay, that's the square root of -1. Up until now, we haven't been able to do anything with negatives under a radical. We just say error on your calculator. So now that we know what it is, it's an I, this is an imaginary number. So if we have I being this, that means that I squared is just -1. So if you take I squared, you get a -1. Now what we want to do with this is we now want to evaluate this one. This is a positive square root, and underneath my square root is a -49. What we want to do is evaluate. So this can be written as a -1 times a 49. This is how we break down radicals. Now, the square root of a -1, hey look, that's back here, that's just an I. So this is going to be replaced with I. The square root of 49 is going to be replaced with 7. And instead of writing it like this, it's just good math to write it as 7I. So the square root of a -49, the answer is 7I. Let's try another one. Let's try the square root of a -7. For this one, it's going to be a -1 multiplying by a -7 under the radical. Again, hopefully you remember that the square root of a -1 is going to be I. And then this is the square root of 7. It doesn't reduce, we leave it like that. Notice here I put the number first and then I second. Here I comes first and the square root comes second. The reason why we put I first is that we don't want to accidentally think that it's going under the square root. So to make sure that we don't put it under the square root, it comes before. So square root of -49 was 7I. This is going to be an I square root of 7. Let's do a couple more. When you see this, this is one number. I know it looks like you're adding things, and you are, but this is considered a number. It's 3 plus 2I. Because I, this part, is the imaginary part, you cannot add a real number with an imaginary number. So we don't add these together. But if I take this imaginary number and I add it to this imaginary number, again, remember, this is one number, this is one number. I'm adding my two imaginary numbers together. When I do this, I can add the real parts together, and then I can add the imaginary parts together to get one number at the end. So you can think about this as where I would be an X and combine like terms. So since everything's addition, I can just add as if there were no parentheses. So I can take my 3 and my 7 and add them to get 10. Then I can take these and add them to get 4I. So when you add this imaginary number plus another one, you just add your like terms, and this is going to be your new imaginary number. What happens if we subtract them? So I'm going to take my same numbers I had before. This time I'm just going to subtract. So I'm taking this imaginary number and I'm subtracting it from that one. Well, again, if we think about this as combining like terms, this is a -1 outside of parentheses, so we need to subtract the whole thing, or distribute the negative. So this becomes 3 plus 2I over here, and when you distribute, it becomes -7 minus 2I. Now we just combine our like terms like normal. So I take my 3 and my -7 to get a -4. Then the +2 and the -2 are going to make them be 0, so I get 0 I's. Since I have no I's, my answer is a -4. That tells me that this imaginary number minus that imaginary number gave me a real answer, a real solution. So now let's work on multiplication and division. So first we're going to multiply these two numbers together. Now, this is an imaginary number plus times an imaginary number. Since I'm multiplying my imaginary numbers, I have to do it as if they were binomials. So I have to multiply this as if the i's were x's. So first I'm going to do my first, outside, inside, last. So I multiply these two and get 25. Then I multiply these two and get 15i. This is going to give me a negative 15i. And this, when I multiply them together, as if i's were x's, I would get a negative 9i squared. When you combine your like terms, your 15 and your negative 15 are going to be a 0. So you're left with 25 minus 9i squared. Now, when we have imaginary numbers, we don't like them to be squared, because we know that I squared is just negative 1. So whenever you see an I squared, you just put a negative 1 in. Now we evaluate. The 9 times the negative 1 is going to give me a positive 9. And I get 34. So when you multiply your two imaginary numbers, you FOIL it out, combine your like terms. If you see I squared, you replace it with a negative 1, and then that's your answer. Let's try another one where we multiply. So again, we want to multiply these together. We want to consider it as a binomial where the i's were going to act like x's for a little while. So I multiply my first, outside, inside, and last. My first numbers, 4 times a negative 5, give me a negative 20. My 4 times the 3i is going to give me a positive 12i. This here is going to give me a positive 20i. And this is going to give me a negative 12i squared. So now that I multiplied it out, I want to combine my like terms. I have a negative 20 plus 32i minus 12i squared. Again, we don't like to have an I squared. So we know that I squared is a negative 1. So I put a negative 1 in here. Now I want to multiply these two, my negative 12 and my negative 1 is going to give me a positive 12. Now I have like terms. I have a number here and a real number here. I want to add the real numbers together. So a negative 20 and a positive 12 gives me a negative 8 plus 32i. So when we multiply this together, we get this imaginary number.